So next, I'm excited to introduce Dr. Kim Goodspeed, who leads the GTX-102 clinical trial at Ultragenyx. She's going to be talking to us about a framework that we've heard about before, but not explicitly, called the MDRI, or the Multi-Domain Responder Index, which really can capture some of the meaningful changes in Angelman syndrome. So I'm going to let her explain to you exactly what that is.
Almost there. Hello, everybody. What great talks we've had today, right? So, as Allison mentioned, I'm Kim Goodspeed. I'm the clinical lead for GTX-102 at Ultragenyx. Really honored to be here. I'm a child neurologist by training, and just thrilled to be getting to work with this community still. So, first and foremost, thank you. Thanks for being here, for listening. Thanks to all our families who have participated in our trials, and all of our investigators and your study teams who have made those trials happen. So, without you guys, none of this data would exist. And because we're have some opportunities here, I wanted to be able to dive into the methodology behind our MDRI. So that's really what we're going to kind of focus on today, is what is this tool that we've kind of shown you a couple of times now, but we can dive into it a little bit deeper. But first and foremost, GTX-102 is not an approved product, right? So it's an investigational drug, and the data we are going to look at today is from an interim data from an open label study, so it's not definitive. And again, I really want to focus on the methodology today and kind of what are the nuts and bolts of the MDRI, the Multi-Domain Responder Index. But first, can I also tell you that the reason we think about things like the MDRI is because we know that in especially rare disease clinical trials, selecting a single primary efficacy endpoint can be really challenging. But that's generally how clinical trials are set up. So they're designed to evaluate efficacy based on this one symptom. And you measure it in one particular way, and you need to have most of the trial participants improve in that particular symptom. So in order to demonstrate that therapeutic benefit on that particular symptom, you probably need to make sure that most of the individuals in the trial have that symptom when they come into the trial. Well, in some scenarios, that might end up narrowing the population of individuals that you get to study. And then you get into some questions around, well, how much can we generalize this data if we had to limit our study population to this one particular symptom? But even more than that, I think we're in a new era, right? We learned all kinds of interesting things about ASOs, gene therapies, CRISPR therapies this morning. These are all designed to treat the underlying cause of Angelman syndrome, which we know doesn't manifest as just one symptom. So if we're treating the underlying cause, you can imagine that individuals are going to benefit in different ways because they have different symptoms at the beginning. And so we know that even drugs that exist today can impact patients in many, many different ways, but the trials that were used to approve those drugs really had to rely on that single primary efficacy endpoint. So our solution is the MDRI, so the Multi-Domain Responder Index, and it's a way to evaluate the data looking at all of these different symptom domains at a single time in one analytical tool. So let's talk about what it is. So again, it's an analytical strategy. It's a tool that we can use to see different symptoms and how individual participants from that trial respond to each of those different symptoms, and then kind of tally up the data to see the overall responder rate. So it's important that each of these symptoms that we're measuring are clinically distinct and are important. And so these are the 5 we've identified for Angelman syndrome, and we'll talk a little bit more about that, but most of that data actually came from y'all again. So from your disease concept studies, your natural history studies, you have taught us what is important and what we need to measure, and so those are the key aspects that we've focused on. Now, what is the MDRI not? It is not a composite endpoint, which it often gets kind of confused or lumped with. The difference that I think is the main difference is that in the MDRI, we get to measure different symptoms with different endpoints, and they're all thought to be clinically meaningful for the population. A composite endpoint is really taking one symptom, but measuring that symptom in a lot of different ways. So this coronary artery example here at the bottom is showing you that we have all these different ways that we can measure coronary artery disease, from kind of milder to more severe ways of measuring it, versus taking different symptoms and manifestations of Angelman syndrome. So it's a little bit of a nuanced difference, but an important one. So how does it work? you initially identify anywhere from 4 to 6, we picked the sweet spot of 5 for this trial, clinically meaningful domains, so symptoms. And they need to be important, so they have to be things that you care about as a community, and they need to be independent and be able to measure it independently. And then we identify a clinical endpoint that appropriately measures each of those symptoms. And then we define a meaningful score difference. So what is the smallest change that we think would be an indicator of improvement or worsening? And then we assign a score to that. So here in the middle of the screen, we've got the pink, the white, and the green boxes. So if that meaningful score difference is met or surpassed in the direction of improvement, we assign that a score of +1. If it's met or surpassed in the direction of worsening, we assign it a score of -1 and give it a pink color. If it falls somewhere in the middle, we say, we're not sure if that's clinically meaningful or not. We don't know if that's a true treatment effect. And so we leave that box white and we give it a score of 0. You tally up all of these scores to give you your net response. So like in this little theoretical example here, domain 1 is a +1 because they improved. Domain 2 and 5, there wasn't a clear change, so that's a 0 point. 3 gets a +1, 4 is a -1. Sum that up, you get a +1 net score. Then you look at this through the entire group, apply some statistical analyses to it, and decide if it's statistically significant or not. And we've already said that each of these boxes is clinically meaningful, so then we get to apply the statistical analysis on top of that. And then we display the results as a responder index. So for Angelman syndrome, we started with the domains. These really truly came from your conceptual model. So what are the things that are the unmet need and things that we can measure in a trial and that are important to you that they could potentially improve with treatment? So sleep, motor, behavior, communication, cognition. And then the next, sorry, we've got some formatting stuff that was not on my laptop, but then we identify which endpoints we assign to each of those. So this data comes from our phase 1/2 data. We measured, for example, sleep in many different ways, and then we look at our data and say, which one do we think is actually capturing what families care about? And we also ask you, which of these measures seems like it's capturing what you care about, and what do you care about? And then we land on which endpoint we think is the most appropriate to assign to that clinical domain. So in this case, we used our Angelman Syndrome Severity Assessment Scale. It's a scale that's completed by the clinician, and we're using the sleep domain, and so forth throughout each of those clinical endpoints. Then we define the MSD, or the meaningful score difference. This term has shifted a lot over time, so you may have heard it called an MID, or minimal important difference before. There's a number of different acronyms, but essentially all it means is what is that score threshold that we think if we go beyond it, that would mean a clinical improvement that would be meaningful to you. So they're all listed here, and that, again, formatting is coming out kind of wonky, but it's a ±1 for the first two, a ±6 for the next two, and a ±5 for the last one. And then we look at it across all of these kids. This is a sampling from our cohorts A and B. And so to orient you to that graph, we have each column representing an individual symptom domain that's being measured by one of those clinical endpoints. Each row is a participant, and then we code each box by that color. So if they met or surpassed the meaningful score difference in the improvement direction, we color it green. If they met or surpassed in the worsening direction, we color it pink. And if there was not a clear change or wasn't a sufficient change to meet either of those thresholds, we leave it white. Every green box gets a +1, every white box gets a 0, and every pink box gets a -1. So let's look at a couple of examples. So participant 1 from the top of that last graph, they had an improvement in each one of these domains. So surpassed each of those clinically meaningful thresholds in the direction of improvement. So 1 + 1 + 1 + 1 + 1 gives us 5. That's the max score. Another participant, though, that had some variable responses, improved in 3 domains that are all colored green. They didn't have a clear change in 2 domains, and so that gives us an overall score of +3 for this individual. And one more example. So we've got a score, a domain that wasn't clearly changed. We've got 2 domains that met or surpassed that clinical worsening. And we've got 2 domains that met or surpassed clinical improvement. And they get a net score of 0. So it's a really interesting way to be able to look at all of these kids. I'm actually going to go back to this slide one more time. But it's a nice way to look at all these kids from a bird's eye view. And overall, you can see that kids are responding in different ways. And some kids aren't responding in certain domains. And we don't know if that's because they didn't have that symptom to begin with and it just was never a problem, so it didn't need to change, or what exactly happens. But it does give us a sense that we can get these variable responses. The other nice thing is you're not just limited to this analysis. It's a super powerful tool in conjunction with everything else we do to analyze our data and be able to look at everything on the continuous scale. So we're looking at it in graphs where we're plotting it out by group and understanding what the group is also doing on each one of these measures individually. So hopefully I have shared a little bit of the secret sauce behind the MDRI. Again, it's an analytical tool. It's a different way to visualize the data and understand the clinically meaningful improvements that we see across multiple domains using a single tool. It allows for enrollment of a broader population potentially, and allows you to also then look at safety across a more diverse population, which can also help with our interpretability and generalizability of all of these results. So we think it's a great tool. We think it's especially great in populations like yours that have complex phenotypes, complex presentations, and a really nice way to be able to analyze the data. Thank you.
Thank you for that, and thank you for the willingness and the attempt to actually try to capture our kids holistically rather than try to put them in separate buckets, of which we know that Angelman syndrome is a diverse and global disorder, and holistic capture of clinical domains that are of meaning is incredibly important to these children.